Okay, this is the P4 paper from June 2021. It's question number 4, and as we can see quite clearly, this is integration and integration by substitution. So let's jump in straight away and make a start to it. So we've got the integral between 4 and 1 of 10 over 5x plus 2x root x dx. And quite helpfully, they're telling me to make the substitution that u equals root x, or in other words, u equals x to the half. Now, I always tell my students when I'm doing this that the most important thing when we're trying to substitute in here, we've got to get rid of the 5x, we've got to get rid of the x root x, but the most important thing is to get rid of that dx, and if I do that first, that will then mean that I can tidy up everything else afterwards. So if I've got u equals x to the half, then du by dx, differentiate, we multiply by the power, take one off the power, and now I want to tidy this up and get dx equals from here. So I'm going to get that du equals 1 over 2x to the half dx. I've just taken that up there and I've also tidied up the minus a half part. So in other words, dx is going to be equal to 2x to the half du will equal dx. So when I'm subbing that in, I'm going to end up with 2x to the half on the top, and then we'll see where that leaves us when I'm doing the rest of the substitution. The other thing I do, if we've got limits, I tend to do this here as well. For my limits, this is nice and straightforward and get marks for it, so I always tend to jump straight into this. We've got that u equals x to the half, so we've got that u equals 4 to the half is going to give me u equals 2, and u equals 1 to the half is going to give me u equals 1. So I've now got my two limits there. So now when I'm substituting in, I had the integral between, we might as well put those limits in now, u equals 2 and u equals 1, but I'm going to have a mixture of x's and u's just at the moment. I've got 10 over 5x plus 2x. Well, 2x root x is 2x x to the half. Let's just tidy that up. And then my dx now, this is the only change I'm making, is 2x to the half du here. So what I can now do is look and see, can I cancel this? Well, I can cancel it with the x to the half there, and I can actually cancel it in there if I think 5x is 5x to the half x to the half, and I can cancel one of them. So hopefully I'm not doing that too quickly for you. We can say this is between u equals 2 and u equals 1. 10 over, so I've now got 5x to the half, because I divided this by x to the half, I've cancelled out an x to the half, plus 2x, and all the other x to the halves have gone. I tell you what, let's make that 20 rather than 10, because then I can take account of the fact that I'm doing 2 times 10 there at the same time. So it's entirely up to you how much of this stuff you do all in one go. And now the only thing I've got to do now is to get rid of the x to the halves using the substitution. So now my integral becomes between 2 and 1. Let's take the 20 out at this stage, and I've got 1 over 5u, because I've got x to the half, plus 2, and then x again. X is x to the half times x to the half. So we've got that as now my integral. So when we get to this stage of the integral, it could be that it just jumps out straight away. In this particular case, what we're going to do is we're going to have to use partial fractions to solve this. We're going to have 1 over, let's take u out as a factor, 5 plus 2u here, that couldn't really be any more classic as to a partial fraction question. So let's just go ahead and do that. So if I'm doing partial fractions, I almost tell them I'm going to do my partial fractions here. So partial fractions, and I've got 1 over u, 5 plus 2u, So that's A over U and B over 5 plus 2U. And then just go through the standard partial fractions protocol. So 5 plus 2U here, plus BU here, all over U, 5 plus 2U. That's going to be equal to 1 over 5. And then we can just equate top line, equate the numerator. So we're going to get 1 is equal to A, 5 plus 2U, plus B, U. And then, shouldn't really spend too much time talking about this because this should be really standard for somebody who's a P4 student. Set U equals 0, and I'm going to get 1 is equal to 5A there. So A is a fifth. Set U equal to, I want to get rid of the other bracket, so I'm going to set U equal to minus 5 over 2. If you struggle with this, go back and look at some of my other videos on partial fractions. We're going to get here, if we do that, 1 is equal to, obviously, no lots of A, and we'll get minus 5B over 2 here, so that means that B will work out to be minus 2/5. And so what we can then say is, all right then, so the integral between 20 and 1 of 2, 1 over U 5 plus 2U du is equal to 20, the integral between 2 and 1 of 1 over 5U minus 2 over 5 plus 2U du. And I can see here this fifth can cancel out with that 20 there, fifth in both of them. So I'll get 4 outside my integral here. So I think I've actually got equals the integral between 2 and 1 of 4. I've got 1 over U, and I've got minus 2 over 5 plus 2U du. Now, even in the question, I didn't really talk about the question, but it said that we're going to have logs in our answer there, so that should cause us no problems now. We're really happily on the right sort of track here, that the integral of this, the integral of this works out to be the integral of 1 over U is log U, and the integral of 2 over 5 plus 2U would be log 5 plus 2U, but then because of the 2U, we have a half, and then we've already got the 2 in there. I'm doing that quite slowly. You might have done that all in one go there, because obviously the 2 and the half are going to cancel. All between 2 and 1, which then gives us 4. So what have I got here? I've got log U minus log 5 plus 2U. Now, all between 2 and 1 here. Stick those values in. We're going to get equals 4 log 2 minus log 9 minus, and then log 1, which is it. I'll put it in, but log 1 minus log 7 here. Put a square bracket around all of that. But obviously, log 1 is equal to 0, so that goes. Minus log 7 makes plus log 7. So we get, it's just how many steps you want to do with this now. This is 4 log 2 minus log 9 plus log 7. If I was doing this myself, I already would put the answer in for this. But just take your time over it. If we tidy that up, that's 4 log. The log 2 and the log 7 makes log 14. But minus log 9 we write as divided by log 9 there. Why did I leave it like that? Because in the question they said they wanted it in that format there. So A and B are those values that we found. Right, nice question that. Hopefully all of that makes sense to you.